So hi guys, welcome to High Entropy Day 86 of DSA learning. It's it's day 86 and let's begin without wasting a time. And yesterday I was trying to solve a problem, but somehow I got the intuition how to solve it, but solution I'm not getting because the way I'm approaching the problem, it's like I have to return two things at a time. And when it comes to return two values, I'm just confused. Like I know in Python we can use like a tuple and store tuple, but still I feel like it's not intuitive. So I just wanted to see the right approach to solve it. Okay, so let's begin, and I will share my screen. And let's begin without wasting time. So I will watch video first because I tried a lot, but somehow I'm not able to build the solution for it. So let's do it.
Do true. If I go in the other way where I say, okay, listen, let's keep this and let's try to solve T XOR F at first. Now, true XOR F will be nothing but true, and then there is expression to get true. There are two ways that can do. We'll have false and a XOR, and then it's followed by an operand, then followed by a true or false, followed by an operand, followed by a true or false, followed by an operand, followed by a true and false, followed by an operand, followed by a true and false, followed by an operand. Something I definitely know is either I solve this guy at first and then this. Then over here I can decide whether to solve this or that. That is a different thing. But when I start, can I think this problem in this certain way that either I solve this and this, or either I say this or 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 this. So can I say at every operand, I can do a partition stating I solve the left sub problem, I solve the right sub problem, right? Or I can say on this operand, I solve the left sub problem and the right sub problem. Or I can say on this operand, I solve the left sub problem and the right sub problem. Or I can say on this operand, I solve the left sub problem and the right sub problem. Or I can say on this operand, I'll solve the left sub problem and the right sub problem. So on every operand, I'm actually breaking it down into sub problems. And then imagine if I'm solving this, this will give you a 2. And then on this, like if I try to write this sub problem, like if I just do it in yellowish, F or E and F XOR E XOR F. Now on this, again you can do the same thing. Either you solve this and this, either you solve this or this, either you solve this or this, either you solve this or this, and again this will be solved. So am I getting a pattern of breaking it down on the operand? Yes, I'm getting a pattern to break it down on the operand. So why don't I break it down on the operand? Let's actually break it down on the operand. So can I say initially I have this entire expression to be solved. So probably we know this is nothing but similar to something like MCM where we had A, B, C, D, E, F. We decided this will be solved at first and this will be solved at first. So can we actually think this problem in that direction? We definitely can, and that is what we will move across and try to think. So can I say initially I have this entire range. I can call this as I and J as we have been doing in all the other problems. I can say this is the entire range and I'm looking to evaluate, right, starting from the true to this last guy. I can say this is the initial range and I'm looking to evaluate. Now can I say if I'm standing at I can always do a partition on an operand, on an operand, on an operand, on an operand, on an operand. I definitely can do. And that operand can be this guy, this guy, this guy, or this guy, or this guy. Do you see a pattern evolving? Do you see a pattern evolving? Yes. The operands are at a distance of 2 indexes. The operands are at a distance of 2 indexes. I can definitely vouch for that the operands are or will always be at a difference of 2, right? And if this is the entire expression that we are solving, the first operand will be starting from I plus 1, then you can do a plus 2, then you can again do a plus 2, then you can again do a plus 2 in order to find your operands, and you can go on till j minus 1 because that is where the last operand will be. So I have practically understood where can I do a partition. That is definite enough that where can I do a partition. But now how do I solve the problem? Imagine, let me just erase this blue lines because those are a lot of lines. Okay, now this was the entire range, right? Imagine I am doing an operand, like I am trying to do a partition here. This is an AND operator. This is an AND operator. So apparently, this is the sub problem that I'm saying to solve. This is the sub problem that I'm saying to solve. Correct? So if this partition is done at an index, so can I say the number of I need to solve this partition, which is f of I comma index minus 1. This belongs to this, and this is nothing but f of index plus 1 comma j as usual. This is the left sub problem. This is the right sub problem. Now, since there is an AND operator, what should the left sub problem give you back? What should the left sub problem give you back? And what should the right sub problem give you back? That is a simple enough question that I am asking you. So we know that if there is an AND operator, and we know AND will, because you are saying there is a left guy, and there is an AND, and there is a right guy. So I know one thing for sure, this left has to yield a true. This left has to yield a true. And this right has to yield a true. That is for sure. The number of ways, can I say, since I'm looking for the total number of ways to make true, can I say the number of ways in which the left yields true? Imagine it is x number of ways. and the number of ways the right yields true is y. So can I say the total ways will be x into y, where x is the number of ways in which the left guy gives true, the left is true, and similarly y is number of ways in which the right is true. Understood? So that was for AND operator. That was for AND operator. And similarly, if I think of other patterns where we are doing a partition at, imagine OR, and there is a left guy that has to be solved, and there is a right guy which has to be solved. So if it's an OR operator, when does an OR operator gives you a true? Like when will this yield a true? Can I say if the left subproblem yields true and the right subproblem yields a true? And imagine this is x1 ways, this is x2 ways. The left subproblem yields true or gives you true in x1 ways. The right subproblem gives you true in x2 ways. So can I say the number of ways will be x1 into x2? Is it just limited to true? No, because it is an OR operator. So I can say if the right yields false in x3 ways, because this right subproblem might also give you a false, might give you a false. And if the number of ways in which it gives you a false is x3, so what you say is, hey listen, there is true on the left, there is false on the right. So true and false, if it's an OR operator, will also yield a true. True or false will also yield a true. Thereby the number of ways can also be x1. Number of ways in which you can make true on the left, number of ways in which you can make false on the right. Similarly, can I say, if I make false in x4 ways, I can again say false from here, true from here will also yield a true. Thereby x2 into x4. So I can say the total ways will be this. I figure out the number of ways of true, number of ways of true, number of false, and total will be this if it's an OR operator. If it's a simple AND, then it's an easy one. It is just x into y. If it is OR, then it becomes x1 into x2, x1 into x3, x2 into x4, right? And similarly, if it's a XOR, let's understand when does a XOR gives you a true. So XOR is basically if it's a trues or true, it will give you a false. If it's a true. So two ways in which you can trues to be x1. So I can say it's true into false, which is x1 into x4. That's true into false, and false, which is x3 into 2, which is x2. So for the XOR, whenever there is a XOR operator, this problem, I have to figure out the number of ways in which it can be true and in which it can be false. So I have to solve it in two ways. I have to figure out in how many ways it can be true, in how many ways it can be false. Understood? Now, as of now, we are just solving a true problem where we are given a range ij and we are trying to evaluate it to true. But now, whatever range, because this is a problem and this is a problem, and this might yield a true, this might yield a true, or this subproblem might be a false. So whatever range I'm solving, yes, whatever range I am solving, I need to figure out in how many ways it can be made true, in how many ways it can be made false. So I'm looking to make it true, or I'm looking to make it false. I have to figure out both the ways. So apparently, can I just carry a third variable? I can. So what I'll do is, I know this is the range that I'm looking to solve, and I will say 1 or 0, like true or false, is true. Like, are you looking for true? So I'll have this guy is true. If I'm looking to figure out the number of ways in which I can need to have it true, I'll have it as 1 or I'll have it as 0. Like initially when you start, let's go back and understand. Initially this is the guy, and if I try to write down the indexes, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I will call it f of 0, 10 because the range is from 0 to 10. So I'll call it 0 to 10, and this is the initial expression. And the question states, in how many ways can you make the initial expression true? So I will call this true as 1 because I'm looking for true, because I'm looking for the number of true. So I'll call it as 1. Got it? Perfect. So what I'll do is, I will simply have it as is true, and initially I will start off with f of 0, n minus 1 and 1 because I'm looking for the number of trues. I'm looking for the number of ways in which you can make true the entire stuff. So that's why I initially start with 1. But whenever you're solving the left and right subproblem, make sure you take care of whether you need true or whether you need false. Got it? So what will be the base case in partition DP? Now you know one thing for sure, if the partition is over, which is this case, I greater than j, this is partition over. And there are 0 ways in which you can make it true. If there is no partition, there is no true or no false. So you just return a 0 as the standard way. Or the other way. Now, when do you actually get it true and false? Try to realize, try to think. So imagine if I'm just giving you this portion, true or false XOR true. Imagine. Now, whenever you're trying to solve this subproblem at play, this was the initial subproblem, I and j, and then you broke it down into solving, saying just solve this, where I is this, j is this, and also solve this f XOR t, where I is this, j is this. And the other way you're saying, solve this subproblem, where I is this, j is this, and solve this subproblem where I is this, j is this. Now tell me one thing. If this is a subproblem where I and j is he himself, where I and j is he himself, what will this guy give? This guy will give one way to make it true. This guy will give one way to make it true. Since I was looking to make this guy as true, this will give true as one way because I is equal to j and it was true. Similarly over here, single guy, this will also give you one way. So can I say if I is equal to j, then that is when I can say it's an end. if the single guy, you know it's a true or false. If the single guy, it will either be true or it will either be false. The single partition will either be true or false. And if your is true is looking for one, like if you're just looking for one, if you're passed on one, which means you're saying how many trues are there, in how many ways can you make it true? You will say, okay, if is true is one, then I will return you whatever is at my partition. If that is true, I'll return a true, or else it will return a false. This will make sure that it returns a 1 if true, 0 if false. Remember this. And if it is not, if is true is like you're looking for false. If you're looking for false, remember this. If you're looking for false, in how many ways can you make it false? Then I will say, okay, then kindly return if the partition is false, then only return 1. If the partition is false, return 1 if false, return 0 if true. So in this way, you can say that partition at the end of the day is true. If you're looking for true, it's one way. If you're looking for false, it's one way. Otherwise, it's not. So this is how the base case can easily be written. Once you have written the base case, we will get back and see, okay, where is the partition? Now, where can you make the partition? If this is I, this is j, I already told you. You start from I plus 1 and you go until j minus 1 with a transition of plus 2, plus 2, plus 2. You just go across and make the partition. So what you'll do is you'll just go across and try to make the partition, right, starting from index equal to I plus 1, index lesser than equal to j minus 1, and index equal to index plus 2. You'll always make a jump of plus 2. So imagine I'm saying x1 is the number of ways in which you can make the left partition true. Or let's have it a name better. Left partition can be made true in the number of ways as I comma n minus 1 is the left partition. I'm looking the left partition to be true. So 1, the left partition can be made false in I comma n minus 1 comma 0. The right partition can be made true in index plus 1 comma j is the right partition comma 1 to 2 you send in a 1 will we made. For an example, if your operand is, by the way, we are looking, so you'll count. And if you remember the default, you add these. First you will try this and figure out the number of ways and add it. Then you will try this, figure out the number of ways and you'll add it. If the operand is somewhere and I know the ways will be nothing but we just need true on the both sides. So left will be true and right will be true. Just please add them up. Similarly, you go on applying the formula for you return the total number of ways. Yes, you just this correct. No, this is not correct. Why is this not correct? Because this just gives you 2 ways. But if you remember, your function had a parameter. Does it want true? It might want false. It might want false. So on an and, if I'm counting, only if I want true, then I come across and do a true into true. What if I want false? Then the number of ways will be very simple. If I want false, it will be either one of them has to be false. So either the right one has to be false or the left one has to be false, or the both has to be false. That will also work.
Huh?
So if the left is true and the right is false, it will give you a false. If the left is false and the right is true, it will also give you a false. If both of them are false, it will also give you a false. So if you're looking for false ways, this is how you count it. If you're looking for
Okay, got it.
true ways, this is how you count it. Similarly for OR you can write, similarly for XOR you can write, and you can just return the number of ways. That's how you do it. So we're definitely applying recursion, right? So what are we applying? We are trying to apply recursion. And if we are applying recursion, the time complexity over here will be exponential. And in order to get it better, you will see if there are overlapping, you'll see over it, all are changing parameters. It can be from n minus 1 to 0. So I'll be requiring a 3D dp of n, and 2, a 3D dp of n, and 2, and you will be just writing it over here like dp of I, dp of j, and is true is equal to ways. And similarly, you can just plunge that in over here, right over here, yeah, right over here. If that dp, you will end up volatile into n into these are the number of states that you're using. Inside every state, you're running a for loop for the partition to be made. So this is almost near about to n cube. What about the space complexity? You're trying to memorize it in n square into 2 plus an auxiliary because you're trying to shrink it down. So auxiliary stack space will be there. So this will be the time complexity and space complexity. In the next step, we'll try to code this up. Out of ways, it's long, step to 0. For int index, the partition will start from the and will also give you false. So all of these ways plus left for all of these, you can simply return the ways. It was a long one, isn't it? So over here, what you can do is you can just return f of 0 comma expression dot and go as a double one vector. Amazing. So right at the next step, just make sure if dp of ij is true is not equal to -1, return dp of ij is true. Okay, once you've done this, right at the last step, write this and you will see this will be running fine. So my bad, this is running fine. make sure you write the base cases by yourself, and right after that, just copy paste the recurrence under the three nested loops. Maybe four nested loops. It'll get a lot complex. So let's not get deep into that. Instead of that, let's keep it simple to the memorization solution. But I highly appreciate if one among you can write the tabulation code by following the format that I have taught and put it in the comment section. That will be
Okay, so simple approach. What is it? You have given an expression. Let's say true, or false, or true, or and false. And or job. Now the thing is simply we are going to create a function. It will represent I, j, and third whether you are calculating is true or false, and let's say memorization, let's forget about it, and another thing is str. So this is the thing. If I greater than j, what does it mean? You have number of ways to make true or false. Return 0. If I equals to j, that means there is only one, and so it's definitely it will be uh, pointing to particular, you can say, item. So one thing I'll do, I equals to j, that means you have only single true or false. So if is true, that means we are looking for true. So return if it is true, then it will return 1. So false one. For other conditions, simply for k in range I and I plus 1. I plus 1 represents the first operand, and the second will be j minus 1. So here we will keep till j because we want j minus 1. So if we are keeping till j, then that means the range will be and 2. So basically you are adding 2 adding each time. Now you got an operand, so you will say lt is equals to self dot, let's do solve. I will remain same, k will be whatever the point that you are doing is true equals to 1, and rt will be solve I not I k plus 1 to z is true equals to false. True. Another point, result is equals to min. So result max I will do. We need to find the total count. Total equals to 0. K equals to let's take start with the AND. So if I am taking AND, what does it mean? It means both sides should be true. If it is AND and I'm looking for true values only, so if you are looking for true, both should be true. So here I will say written whatever you are getting from left side true, and whatever you are getting from right. So lt plus rt. No. Okay. From left you are getting, from right you are getting something. And if you want to make a different expression, lt into rt. Else another part. Here you will say, okay, you want false. So lf left false and rf one option, and lt into rf plus lf into rd. Okay, these are options. If k equals to or, what does it mean? There are two conditions. If is true, we are looking for true. That means if you are looking for true, return only the false condition. So lt into rd, where both are true, or it could be lf into rd. Else if it is not the same, I mean if it is not true, you are looking for false. So false are in the or are only possible written lf into rf, both are false. Okay, so else part is something. Okay, else means how, why are you saying so many times okay. Zor. So if we are looking for is true, that means you are looking for is true, and is true is only possible written LT to RF plus RT into LF. If you are looking for false, then both should be LT into RD plus LF into RF. Define, solve, self, and here ij is true. I'm using the same approach that whatever it did have. S. If I greater than j, that means it's already over. Uh, you already crossed all the expression and elements, all the all the different operands and operator of the expression. So another thing, if I equals to j, that means you have only one operand. So now, if you are looking for is true, that means you are looking for true. So return uh, s of I equals to true. If it is true, then it will return one, return true. And else, that means you are looking for false. Return s of I equals to false. If it is false, then you will say okay, I'm looking for false. It is false, and the count will be one. Okay, so this is one condition. If it is not the base condition, then for k in range, you will say okay, I is nothing but the operand, so I plus 1 will be the first, and j will be j, and 2 j minus 1 at least. So this is one condition. Now for you got the k, for each k you have okay total 0. So you have LF LT is equals to self solve I to k minus 1 and is true 1. Okay, and s. Another one is RT. Okay, one thing I will do. So LF means left false, and here I to k minus 1, and instead of true you will say 0. And RT, right true, self I, here you will be range will change k plus 1 to j, yes, till j 1. You are looking for true, you are looking for false, and right false. Now you got the solution for different things. Now the thing is, if k equals to s of k equals to and ampersand operator op, so if operator is and, that means you need, if is true, then you can return okay, not return bro, you have to do one thing. Total plus equals to what you will do. Basically, we are doing one thing. Somewhere I am missing something or what? It's like just calculating all the possible ways to get true. Total plus equals to okay. Here we is true. So is true means LT and RT should be true. Else total plus equals to LT LF into RF, no, LF into LT into RF. That means one is R RT or LF into RT. This is one condition, and third one is LF into RF. Real if S of K equals to R. If is true, total plus equals to, now you are looking for true in our condition. So LT into RT, this is one condition, both are true. LF into RT or LT into RF. Okay. Else, that means false, you are looking for. Total plus equals to LF into RF. If is true, you are looking for true, then total plus equals to LF into RD plus LT into RF. Both are, anyone is opposite one. Else you are looking for false, true. So what are the conditions false? Total plus equals to LT into RT or LF into RF. Finally, you will say, okay, I got the result for it. Now I can return total. So here what I'm looking for, return self dot solve, and I'll say I'm looking for 0 to n equals to len of n sts and 0 to n minus 1. And another thing you are looking for, I'm looking for true. Okay, once I will do one thing, I will just go through it. I greater than j, that means you are already exceeding the limit, or you already covered all the operands and operators, so return 0. If I equals to j, what does it mean? If both are equal, that means there is only one operand. So if is true you are looking for, then just look for if it is true. If you are looking for false, then this is where you will look for false. Other conditions, total 0 k in range I plus 1. I is the operand, and you want to start from you are looking for different operators that you can make a decision based on that. So keep I plus 1 j2. Okay, it's working. The only thing is, right now I need to take modulo, and also I need to make memoization of it. I definitely am sure it won't work. So mod equals to 10 to the power 9. Percentage mod, here also percentage mod, here also percentage mod. Now I'll take combination of two, and I will say if you are taking sum of two things, then it could be exceeding the number percentage mod, and at the end we are taking whole as and percentage of mod. Percentage mod I'm gonna add. Okay, I mean so many things are there. I mean I just want. What happened now? Where I kept toll? It's still is it's without memoization. Just checking. Wonderful. Test case one. So I'll do this. What? len of expression true. Oh, okay, it's working, but really I'm getting that is acceptable. Now I'll do one thing. I will create memory, and everything will be -1. So there should be I and j can go up to n, and for particular j, there are two values and can be go 0 and 0. For underscore, these are representing true or false, and 0 and range, it could go up to n, and another one for underscore in n. Okay, so we got memory. Now I'll do one thing, mem and here I'll say simply before even calculating anything, ij base condition, else simply I'll say if mem of I and j, and here you will say is true. So whatever, no matter, greater than or equals to 0, return, I did one mistake, if you know, return mem of I j and is true. So this is the thing. Here we need to take -1. I'm not sure if it will work. Logically it should work, but it's giving throwing really. So I use the same solution for here. Optimal is also not working somehow. Oh, okay. It's like you are creating two DP. I will ask ChatGPT for this because I'm expecting. I think there is some sort of this editor has problem also. Oh fuck! I forgot it. Thanks, knock. Okay, so it's working, but the problem is TLA. instinctively after it. I don't know why, but it feels like all. Oh, this is just trained on data, right? So it will give you the same approach. I just want to see the different approaches if I will use some sort of. I okay. Let me do one more approach. I will try to solve it. Define. I will do one thing. DP. I will use the same DP. Same DP. Size will be same. So define not. So mem. I just have one more approach. Where I will just do. I will create memory of 2D dimension. So n will be here something like s len of str s. Okay, now mem. I will keep -1. Okay, -1 represents for particular I and j. What is the value for I in range and no n, and for underscore in range n. So this is one condition. -1 is the placeholder, but if define solve self I and j. If I greater than j, returns 0. 0 comma 0. That means you don't have any true values or any false values. So index. Okay. Another option, if I equals to j, return int of, oh sorry, s I will consider one more value. So int si equals to true, and int s. Okay, one thing I'll do. First I will keep false, second value I will keep true. S of I equals to true, so it will be true. So true and false, this is one condition. If okay, another thing, another, here I'm keeping memory as well. If mem of I and j is greater than, is not equals to -1, okay, it's something else. That means you already got the result. So return mem of I and j. Other options. So for k in range I and I2 I plus 1 to I I is representing the this, so I j plus j and plus 2 with increment of 2. And now I'll say if s of I for k, so for particular k, if s of k equals to, and what does it mean? You are looking for both result. Oh, sorry. First, I need to calculate. So it will be LF. Okay, LF and LT. It's nothing but here you will say self dot solve, and I, you are going to take I to k minus 1, and S memory. Another is R F R T is self dot solve I, no, not I. Here you have k plus 1. J is between k is the point where you are breaking, or that operator you are choosing. S, no, k to j you are keeping, S you are keeping memory intact. Now you will say, okay, if it is and, then simply return, not return, but you will say total you are counting how many total TF equals to 0, and R TT equals to 0. Total true, total false. Now you will set TT, TF, total false. Total false means, what does it mean? Where left is false, right is, okay, first let's create total true. Total true is basically here LT into RT, and so that will percentage by mod. I'm keeping mod as well along the journey. Otherwise, I need to write mod is equals to 10 to the power 9 plus 7. Let's see, it would be easy now. Okay, so you got this, and total false TF will be, okay. Now you wanted to calculate false. False are all the options other than, so LF into RF percentage by mod, and here you just need to say plus equals to, so TT plus, and here I'm gonna say mod again, percentage by mod, LF and LF into RF, and LT into RF percentage by mod, or you can say LF into RT percentage by mod. So these are the three conditions. Okay, another condition would be, okay, you need to do one more thing. Mod, take this one, percentage mod, otherwise how will you do it? And now you need to take TF percentage by mod. Fuck, it will be so many mods. EL if SK equals to, or what does it mean? Total true is equals to LT into RT plus LF into RT, or LT into RF. Now just imagine you are doing one thing. God, percentage mod percentage mod, percentage mod, and now you are saying percentage mod, and here also you are saying it's like I'm working on autopilot mode. Percentage mod. What is time, bro? It's 2:37. Fuck, I was not expecting this much time to solve a problem with different TF, total false, is equals to total false LF into RF, percentage by mod, and here I have to do one more mod because it's a TF. If imagine I made one mistake, it will be very difficult to track. Else you are looking for jar, total true. True means both are opposite. LF into RT plus LT into RF. So these are the conditions where you will get percentage mod, a TD plus oh परसेंटेज मॉड हैंचो इतना टाइम लगेगा क्या इसको करने में आई एम सो सॉरी आई एम लाइक दैट frustration should be released. Okay, so what else, what is remaining? So now I'm looking for not LF to TF, TF TT. Okay, be conscious, bro, focus on it. Okay, so LF into RF plus LT into RT. This is your condition where both are equal. Okay, sorry, percentage mod. I'm just assuming it will work compared to the previous one because here recursions are using lesser recursion, but let's see how it goes. Come on, G. Somewhere I'm just pressing star. Asterisk TF. Hey, okay. This is done. Now you'll say mem of I and J. Okay. Total false and TD. Written mem of I and J. Why do I need to actually? Yeah, it's one order of one operation only, right? So no need to vary. Where did you call it? Written self dot solve I will be 0, J will be n minus 1, S will remain S, mem will remain m, and you will get 2, and you are looking for 1, so you will say 1. Just want to see what is the issue. Actually, this approach I got at the starting only, but I was assuming that there will be simpler approach, but this is not how I'm supposed to do. Still, it's not working. I got TLE after it. Okay, Maybe I'll solve it tomorrow with another approach, but yeah, I will jump to another problem tomorrow for sure. But it's okay. Editorial video. No video is there. Yes, fine, that's all in this video. Thanks, guys. Hmm. At least I thought I forgot to. Thank you so much. Take care. Bye bye. Bye bye. I don't know if anyone is gonna watch even my stream, but no problem. It's more about consistency, consistency, consistency. But somehow tomorrow I have a lead code contest. I need to jump into that in the morning. I will wake up before 8, 3, 5, 8. Let's see.